get started. So, hello everyone. Thank you for being here. Today, I'm going to talk to you about dyeing SLS parts and also the new nylon white powder that came out. My name is Ken. I'm an engineer from Switzerland. I've got a YouTube channel called Exploring the Simulation, where I do engineering projects and like trying to increase the life of existing consumer devices. So, if you're interested in that, you can check it out. And today I want to start with this very famous automotive quote from Henry Ford. I think he said it in the early 1920s. And when he was talking about his Model T, which was one of the first mass-produced cars, he said that it can come in any color the customer wants as long as it's black. And I thought it was kind of funny that over 100 years later, when I was thinking of my own SLS production, I kind of had the same philosophy in mind. But in the last few months, I started seeing things differently. And today I'm here to tell you all about that. And so I'm going to start with this quick video just to show you the product I'm making. It's just 10 seconds. It's an AirPods case that converts the lightning ports of old AirPods to the new standard USB-C. And yeah, here's the video. Awesome. So yeah, it's got flexible electronics inside, and that's what I've been selling for the past few months. And today we'll talk about dyeing and SLS production through the case study of this case. So I've shown a lot of information and given a lot of knowledge already on SLS 3D printing. Today, my goal is not to repeat myself because we have a limited amount of time. So I'll just make a quick summary of where you can find this information if you're more interested. The first video I've done is called Did I Buy a $1 million 3D printer? And it's basically an introduction to the whole Fuse ecosystem where I get the printer, I unbox it, I make a few prints, and yeah, it's just a good starter. And then after that, I did the one-man plastics factory. That was after I released my product and already shipped thousands of parts. So there was a lot of knowledge that I wanted to share on how I approached SLS for production. And I just gave a lot of tips and also, yeah, just like the behind the scenes on production. After that, I did a webinar with Formlabs, just as how I'm doing it today. And that was going deeper into this one-man plastics factory theme. And here I gave even more tips. I also talked about the financial aspect of it, how I was seeing it, and just, yeah, going way deeper into that. And the last one was about 2 to 3 weeks ago, where I got a second printer, started printing in white to try to get my cases in white, and then also dye them and try to get a low-cost dyeing setup. And so today the goal is to bounce back on this video and give even more information and see also some improvement that I've made since then. And so why did I start using nylon white? Well, I get a lot of comments, and some of them are not especially positive. So we have this one that said, I just feel the finish and color is a bit unsightly. Okay. And then we have some a bit less nice, like, accept this look like and then the S word. But here, what was funny was that 80 people agreed to that and gave this comment an upvote. And really, that's just the tip of the iceberg. But I don't really see that as criticism. You know, it's the beauty of the world we live in. Everyone's got different tastes. And so when you're making a product, I think the goal is that you would like it to appeal to as many people as possible, right? And when I see that, well, it just tells me that maybe I'm doing something wrong, or maybe there's a way to improve it and get even more people as potential customers, right, for my product. So after all those comments, I thought, okay, well, maybe this dark gray look that I've had before, that I've shown you in the video, appeals to a small subset of people like me. I think it's great. It's got an industrial look, kind of like a steampunky, but I know some people really don't like it and they wouldn't buy it just because of that. Uh, I could do a whole webinar on why I went with SLS SLS 3D printing, and I've already talked about that in a previous webinar. But today, we'll take the assumption that we already chose SLS 3D printing for our product, and we didn't go with another manufacturing method like injection molding. And the question we want to ask ourselves is why did I get a second printer? Why should you get a second printer if you're already in the ecosystem? And the reason for that was there's multiple. The first one was that while it's perfectly possible to swap the powder in the printer from the dark gray powder to the white powder, I felt like it was a bit of a painful process. You know, you're dealing with a lot of surfaces and very fine powder. So I feel like it would be kind of tricky to do it properly. And I was afraid of cross contamination between the powders, like getting dark gray powder in my white powder. And also, the printer I have right now for with the dark gray powder makes my main source of income. So it prints all those cases, and so I rely on it. It's for production. I don't want to mess with it, right? It needs to be stable. So if I add more capabilities, it needs to complement it and not replace it. Another reason that I call partial redundancy, this is a term I completely made up, but what I mean by that is that when you go into production, you're really trying to upgrade your tools and always get something better, faster, cheaper. But at some point, maybe there is kind of a plateau, right? And you don't know what's the next logical step. And so uh, after that, you start seeing things differently, and you start thinking about redundancy. What happens if one tool goes down? How can I avoid having problems and blocking my whole chain of production? And well, I've started thinking about that and getting a double of everything. And I thought, oh, it would be good if I could have a double of the printer if it goes down too. And here I call it partial redundancy because the second printer prints in another powder. But if one of them goes down, thankfully it's never happened before, uh, I could still funnel people to get the white powder if the gray printer goes down. And so that's why I call it partial redundancy. The last point is speed. So let's say you have 1,000 customers and you only offer parts in dark gray. Well, that one printer you have is going to have to print those 1,000 orders. But now, let's say that you offer parts in both colors, then maybe 600 people get the dark gray version and 400 people get the white version. And then actually you can spread the load on those two print at the same time and fulfill those orders. So it's not twice as fast, but it's still faster. And we'll talk a bit more about speed later. So on the last webinar, I showed pretty much the same list we have here of things you need to get started with SLS 3D printing, and that was for the gray powder. But now for the white powder, if you can see, I've added 2 exclamation marks. So the first one is next to the fuse sift. It seems obvious to me, but maybe it's not obvious for everyone. You can't reuse the fuse sift you already have because it's only made to be used with one kind of powder. And the other exclamation mark next to the fuse blast, where here I think it's a bit less obvious. If you already have your fuse blast, you can't reuse for dark gray powder. You can't reuse it for the with the white powder. Formlabs says it's because it would make your white parts look dirty. I haven't checked, but I think it makes sense because there's always some residual powder that get mixed with the blasting media. So you do need to get a second fuse blast. But the main difference here is the nitrogen generator. So you can see it on the picture on the right. It's super small, sitting next to the printer. So I want to talk about that a bit. So its purpose is to create an inert environment inside the printing chamber. As I understand it, is to prevent yellowing and maintain powder quality over time. The model I got is the one shown here. It's from Flermo. It's a Danish company. I've did a lot of research. I was trying to, get the best bang for my buck, and It was they I showed the model number here. They come in various sizes, but this is really the smallest size you can get that's good enough for one fuse printer, and it just takes 5 minutes to set up. You connect a tube in the nitrogen generator, then another tube in the printer. You set the pressure on the regulator at the output, and you're done. Some recommendations that I would have is that I would I would really recommend having a dedicated space for, or like room for the printer and the generator, because well, first we're dealing with gases, and I maybe felt a bit not paranoid but uncomfortable having that. So it would be great to have a like staying in the same room. So maybe it would be great to have a separate room where you can have a window open and or some ventilation. And also, anyway, it's kind of a it makes some noise, right? And I just couldn't imagine myself working next to it. It would be really hard to focus. So another room would be best. So now let's talk about costs. So if we go quickly on Formlabs' website and we look at the price of powder, we could come to the conclusion that the white powder is 10% more expensive than the dark gray powder. But does that tell the whole story? Well, I wanted to check that. In the previous webinar, I've shown this screenshot of my typical full build print. It's got 70 cases that all have 3 different parts. And so that makes for 210 different parts. And I showed how I was doing my calculations, but basically I came up with the number $1.94 of cost per case of raw gray powder. And for electricity, it was about 3 cents of electricity per case. So now, when we're printing with the white powder, we can assume that it's using roughly the same amount of powder. So if we add 10% to $1.94, that's $2.13. And for electricity, well, I've left this number unknown here because I wanted to dive a bit more into it and double check that. So here we've got the same print file for dark gray and white. For dark gray, it takes about 12 and a half hours. And for white, it's about 21 hours. So it's not an insignificant difference, right? It's about 70 times, it takes about 70% more longer. But the white powder just came out. So I think now it's on print setting 1.1, whereas the gray powder is on 5.3. So I believe that with time, this number will go down. But for now, that's how it is. So we're going to take this number. So now if you start running the numbers, we can see that, on the first row, there's already a difference in consumption of electricity for the printing, but that's quite logical because it just takes longer to print. Then on the second row, we add the nitrogen generator. Maybe here it's a bit surprising that it's pulling about the same amount of electricity as the printer. So I think it's around 540 watts continuously. And so here it's already making a bit of a gap, right? But then for post-processing, we can see that it's slightly more for white because it takes a bit longer, but it's not a huge difference, right? And then I took this figure of 30 cents per kilowatt hour because that's what I'm paying, but it really depends on when you are. It's probably less for you. And so then if we take the amount of electricity that was used, we multiply it by the cost of electricity and divide that by 70, which was the amount of cases in one full build print. We get 10 cents of electricity for the white powder and 3 cents of electricity for the gray powder per case, right? So it is 3 times more electricity to print in white than gray. But if you take that into the grand scheme of things, right, and you add it to the cost of raw powder, maybe it becomes a little bit insignificant, at least for me. And so for my product, the final number that I came up with was that the white powder was about 14% more expensive than the gray powder with electricity. Okay, so now we're going to talk about the main subject of the day, right? Dyeing. There's so little information online. There's some videos for maybe 10 years ago where people are like doing this in their kitchen. and I just it took me a long time of trial and error, a lot of tools bought just to try things out, right? And so today I want to kind of share what my findings were. So hopefully you can find something that suits you and try to replicate this. And so the goal is to have something that's low cost, repeatable, and that works for small batches, right? But that we can repeat over time, and that's quite reliable. I know there are machines out there that do this on a larger scale, but most of the time they cost just as much as the price of the whole fuse setup that I have. So I didn't really want to go in this direction, right? And so there, as I said, the information is hard to find, but there are some information, and most of what you can find, even Formlabs recommends using dyes from a brand called RIT that's used for clothes. I I tried it. I spent a long time trying it and trying to make it work, but I just couldn't get good results with the Formlabs white nylon powder. I just had like kind of spots everywhere on the parts, and it wasn't working well for me. So I know there are ways where you can add some chemicals or like use a different type of RIT dye, but after a while I came to the conclusion that I want to try something radical, something different, and I saw that there were dyes that are actually made for additive manufacturing, and so I gave it a shot. So that's what I bought on the right. It's from a French company, and they're a bit difficult to order, but not impossible. And so as soon as I tried them, I got the perfect result I was looking for in just a minute of dyeing. Whereas for the RIT dye, usually you try to dye them between 30 and 50 minutes, and that sounded like a long time for me. So this 1 minute and perfect result, I just didn't look back, and because it was working for me, I continued like this. And so when you use those types of dyes, I found that there's really 2 points that you need to watch out for to get great result. The first one is heat. So you have to heat up the liquid solution to about 80 degrees and keep it at the temperature, 80 degrees Celsius. And agitation. So the whole liquid needs to be continuously mixed so that the dye is evenly spread in the water. And also your part, if you dip it in a metal cage, it also needs to be spun around so that it doesn't lay flat on the metallic part, and like really it needs to be exposed all around. So the first setup I want to show you today is this one. That's the one I show in the video. It's super cheap. You just use really basic ultrasonic cleaners from China that you can get on Amazon or anywhere. Basically, you pour your dyeing solution in there. You use like a metallic cage. You put your part in, and then you just dip it in and move it around for however long you want. That depends on the color, and then you rinse the part in water, and you've got a dyed part. So as I said, it's really cheap. It's got great agitation, so it uses from the ultrasonic waves. It mixes the liquid and the dye together you can see it on the surface that it's being mixed around. So that's how we agitate, and it scales up in sizes really well. So those cheap ultrasonic cleaners, they go from 1 liter all the way to like 30 liters, even more if you want. But if you've got big parts or you want to do big batches at once, that's a great solution. There are some drawbacks to this solution. The first one is it's very slow to heat, so you got to bring the liquid to temperature at the beginning, right? And those cleaners, usually 80 degrees Celsius, it's the maximum setting they can operate at. And so you put that setting in, and it tries to heat it up to that temperature for hours, but it can barely get there, right? And one way you can speed this up is by putting a lid on, uh, turning on the ultrasonic cleaning function, and just leaving it like that for an hour or two. And that helps speed up the heating. But then it's very noisy. Like if you've used those before, especially the cheap ones, they're very very noisy. So it's not fun to have this around. And there's two more drawbacks that I'm going to talk a bit more later. But basically you can't store the dye in the tank, so you have to take it out every time, put it in a jug, and clean the interior of the tank with isopropyl alcohol and like make sure it's really clean. But we'll talk a bit more about that. And so with this setup, you can still achieve great results. The color gets darker the longer you leave you leave it in there, obviously. So the light colors at the bottom, the darker colors at the top. That's some results that I got from the straight from the beginning. No spots or anything. It was great. And but I thought maybe I could improve this setup a little bit, right? And so the first main pain point was the heating time. So I thought, okay, we could maybe get a slightly larger ultrasonic cleaner and put a sous vide cooker in there to heat up the liquid more quickly. And those sous vide cookers usually they're made for those kinds of temperatures, so they would really bring it up quite quickly. And that works well, right? Then you can leave it in there or remove it, doesn't really matter. Here in the picture, there's no dye liquid, but you can imagine that it's in there. And so that solves that issue of slow heating, but we still have the noise and the cleaning issue. And the main issue with that, as I said, you got to take it out, and the cleaning is just, you use a lot of paper towels, isopropyl alcohol. It just feels messy. And let's say you want to dye one part just because, I don't know, like you forgot to do one and you need to quickly do one, then you have to go through this whole process of cleaning just to do one part. I was hoping for something better. And so the reason you can't keep the dye in there is because the particles from the dye, they don't like water, right? They're trying to fight it, and that's why when you put a plastic part inside, they're gonna jump on it and kind of attach themselves to that plastic part. And also, well, there's something about density, like they're a bit heavier. So if you just leave the dyeing solution overnight sitting, everything's gonna accumulate to the bottom of the jug or the dyeing tank that of the ultrasonic cleaner, and then you'll have a really hard time mixing it up properly. The only way is to put it in like a jug and shake that jug all around really properly to get the image you get on the right, where the dye is properly mixed everywhere, and then you put it back. So I wanted to avoid that, right? Avoid this cleaning step. And so this is the V2 version of my dyeing setup. That I call it the no clean method. So it's the same ultrasonic cleaner, maybe slightly larger, and you fill it up with water, and in the water you put a glass container, and in that glass container you've got your dyeing solution. And basically we use the fact that the ultrasonic waves, they pass through water, but they can also pass through glass. So it will be able to agitate the solution inside the glass container here. And once you're done dyeing your parts, you just take the glass container out, store it, take another one, shake it up really nice, and put it back in the ultrasonic cleaner. So that way, there's no cleanup. You always keep the messy part inside the same tank, and because it's clear, you can really see if you left any, if any dye is stuck at the bottom or anything. It just works really well. So we still have, with this solution, which works great, I can recommend it. We still have the issue that it's quite noisy. And well, I was thinking, okay, now that I have this idea for the glass container, maybe there's a way I could simplify this whole solution and just try something a bit different. And so that's my version 3, I call it. Uh, if you've if you've had some chemistry lessons before, maybe you've seen that before. It's called a stirring hot plate. So it's got a hot plate that same as you would have in your kitchen, right? If it's electric. And inside the hot plate, you have a magnet that's connected to a motor. It's rotating. And in your glass container, you just drop a stir bar. So it's like a little bar that's a white bar that's about this size. And basically, it's going to lock onto the magnetic field and rotate with the motor inside the device. And that's going to agitate your whole mixture. And so that's great because we get great heating. They're usually, the hot plates are really powerful. It stirs really well. We've got something inside that's rotating everything. And most importantly, it's super quiet. You can't hear you just can't hear it work. Maybe the stir bar sometimes makes a little noise, but really it's almost silent. And so here, one thing I would recommend for the glass container, and that I didn't mention in previous slide, but they're a bit hard to source, right? Because you want a glass container that has a big opening at the top and that kind of holds enough liquid. I was looking for something between 3 and 5 liters, and I found the one I'm showing here and on a previous slide. It's a 3.3 liter container with plastic lid from IKEA. And so you want something that holds a lot of liquid, but also that you can seal and has a large opening. And it's not that easy to find, right? But now I gave you the IKEA for reference, maybe it can work. The only issue for the storing hot plate is that you really want a glass container that has a very flat bottom, so the heat transfer between the hot plate and the glass works well. Sadly, the one from IKEA has got a little bit of a curve, but you can fix that with a trick used by chemists where they put a cooking pot, like a metallic cooking pot, fill that with water and place the glass container inside that. And so the heat transfer, there's a great heat transfer between the hot plate and the cooking pot, and then that heats the water, which heats the container. So that's how I solved it here. And so this solution is perfect for small to medium sized parts. And because we have this die that dies really quickly, you can just do your parts 1 by 1 or 2 by 2, 3 by 3, depending on the size, and it goes really quickly. You can really produce a lot of parts this way. And so, as I said, it fixes most of the issues we've had before. I've put scalable sizes in parentheses because, well, you can't get sealable glass containers of infinite sizes, right? So they only go into a certain size. So if you got very large parts, you might still need to go to the die directly in the ultrasonic cleaner solution. But that's why I showed you many solutions today, so that you can choose whichever is best for you. And here on the right, we have this picture of like the glass container, and you can see there's a bit of a hole in the middle. That's the vortex that's created by the stir bar. And we also have a metallic bar that goes in the liquid. That's the temperature probe. And so the heating plate has a temperature probe inside the liquid, and it really tries to bring that liquid to the right temperature. So now some tips to get good results. Um, First, if you've worked before with SLS 3D printed parts, you might know that the surface is quite porous. So uh, if you touch one that's coming straight out of the sandblaster, you will see that it leaves fingerprints quite easily. It's because it absorbs the hand oils on your fingers, right? And but that's only an issue for like maybe a day or two before using. After a while, the whole solution kind of, how do you say, it, it kind of evens itself out, the whole color. And so the solution here is that you always want to wear nitrile gloves or latex gloves between the moment the part is printed to the moment the customer touches it. You never want to touch the part yourself with your hands, right? And there's also something about humidity, where if you live in a very humid environment and you leave your parts out to ambient air for too long, they could absorb some moisture from the air, and then when you dye them, they would maybe react slightly differently, maybe not absorb the dye as well. And so the solution here is to just store them between the moment they're finished printing to the moment you dye in container plastic boxes. That's what I do, at least. So for post-processing, once you're finished dyeing, you want to rinse the parts as soon as possible, because there could be some residual liquid on the surface of the part that continues dyeing a bit more, and then it leaves a spot. So you really want to rinse it as much as possible, as quickly as possible. And with that rinse water, you of course want to make sure to dispose it according to your local regulations, right? that's something you need to check, but depending on where you are. And for drying, that's the easy part. I just leave them in a food dehydrator at 70 degrees Celsius for an hour, and then they're dry and ready to be shipped off, basically. So I was telling you about the parts that kind of absorb the moisture. This is a picture. This is a case that I got back as a warranty return from a customer, and you can see on the right, it's way more black and way darker. And also, when you touch it, you can feel that it got smoothed out, the texture. And this is just after natural use, right? It was just to demonstrate this point. Now, I just want to talk a little bit about consistency. So just so we're on the same page, I feel like when we're talking about dyeing, there's kind of two schools of thoughts. There's the first one that I mentioned at the beginning with very big machines where you have big batches, and you always want to do those big batches one at a time and don't touch it. That's kind of like the approach with cartridges. You use one cartridge for your batch, and then you discard everything, and then you use another cartridge. The issue for me, and maybe for you too, is that I didn't know how many orders I would get on color, even less so what the split would be between colors. So I feel like it kind of defeats the purpose of additive manufacturing to prepare that many parts in advance. I kind of wanted to do it on demand. So if I can have a reusable bath, that's why I'm going this route, and that's why I've showed you those types of solutions today. But how do we make that happen and get consistent results? So here's a little trick, or maybe a step-by-step guide on how to do that. So first, you choose what color you want, right? And like how strong you want it, how dark you want it on the part. So let's say I've got a green and I've decided I'm going to dye it for 60 seconds. Well, then make the I make one part and I keep it in a Ziploc bag, and I call it's the golden sample. You don't touch it anymore; it stays in a Ziploc bag, and then you can continue reusing your dye tank, and maybe every 5 to 10 parts. So every time you dye a part, you keep track of how many you've dyed, but then every 5 to 10 parts, you get the part and you compare it to the golden sample. And you can do this with your eyes, right? Or there's also machines that do this, but I'm doing it by eye, and I'm just looking: is it still really close to the color that I want, or is the colors becoming too light? And so once you finally start to get parts that are too light, it really depends how long you left your parts in there. So that's why I can't give you a number, but it could be after 50, 100 parts, really depends. Then you write down the number after how many parts it starts fading. Let's say it's 100. Maybe take a number that's slightly lower as like a security measure, maybe 90. And then every time you start a new dyeing tank, you know how much is in there. You know you can dye approximately 90 parts in there, and you just do all your parts. And when you reach 90 parts, you discard of the mixture and you start over again. I wouldn't try to add some dye back, some like undiluted dye back in the tank, because I feel like then it's becoming a bit unscientific. What's the ratio between water and dye? And it would be really hard to keep track of and get good results. So I would just start over, and then it kind of gives you an idea of the price of dyeing each part too. So, as a conclusion, we see that we can get some really amazingly bright colors. That's what I was hoping for, right? But you can also dye the dark gray parts, and here it's actually the same dye for the same amount of time, but on the left I've dyed the white part, and on the right I've dyed a dark gray part. And so that's really exciting, because it means that with just 3 dyeing tanks and 2 different types of powder, you can already offer a wide variety of options. Right here, I've got 3, 6, 8 different options, which is really exciting with such a small setup, dyeing setup, of course. And so, yeah, thank you so much for listening. Now I'm gonna look at the comments if there are any on my phone. Uh, here we go. Okay. So if we're looking for a consistent black color, is it satisfactory to use your dye solution with the gray powder? Yeah, I think it's much easier. I haven't tried it yet for me, but from what I've read, it's way better if you want to get black parts. It's way better to dye the dark gray version than the white powder. Do you have experience with fuse blast polishing versus bead blast cleaning? Uh, so I do have experience with the fuse blast polishing setup, not with bead blast cleaning. I'm not sure what that is, but then you ask another question: does the finer surfaces texture still take dye? Yeah, actually they do. Everything takes dye. Just maybe if you have, you need to watch out if you have a very thin wall, maybe less than half a millimeter or something, and all the rest is thicker. This part could dye more, and then you would see it on the you would see it, it would be like a color gradient, so you need to watch out for thicknesses, and that's an issue I've had. Does Fuse Blast leave any residue of that spaghetti mat inside the drum on SLS parts? I've seen some people that say that they had some kind of uh, like white, mm, it's hard, like some kind of dust on the parts. I haven't really had that yet, so I'm not sure where it comes from. So I would say no, at least not for me. They come out really cleanly, and I've passed a lot of parts through that. Um, yeah, do you have any thoughts on vapor smoothing? Yes, I mean, I haven't tried it yet. I would really like to and make a video about it. I just, if there's someone that has a machine that does this and wants me to try it, I'll for sure try it. But it would be interested for watertight parts. I'm just not sure how it affects tolerances right now. That's something I'm a bit concerned. But this is something I definitely want to look into. Do you know how vapor smoothing might work with dyeing? Well, as far as I'm aware, it works just as well, but I haven't tried it, so I can't give you a definite answer for vapor smoothing. On the dyes, the gradient of colors and darkness you have, more times equals darker. How variable, reliable is this? It's really reliable, actually. I've really, if you, most colors I've chosen, I just dye them for 1 minute, and I've had great results. I've seen maybe a bit of difference if you use the ultrasonic cleaner or the stirring hot pot. You could get a bit of a, it would, maybe it doesn't agitate the solution the same way. So I think the time is set on like your dyeing method. And once you've got that, then if you change the size of the pot or something, maybe you would need to try it again. Um, Question from chat. What happens if you try to double dip your parts to the dye and see what happens? You mean in the same dye? I think the color uh, uh, would just get darker, but it could be interesting to try with different dyes. But I'm not sure yet. Right, I haven't tried, but thank you for the tip. I might give it a go. All right, I think that's all the questions. Thank you so much for watching and for your interest, and maybe see you next time.